Hi, everybody, and welcome to today's episode of Echo Live. My name is Anna, and of course, I'm coming to you from the Michigan Science Center's Echo Distance Learning Studio. Today, we are talking about electroscopes. We are going to actually be modifying an activity that we got from the NICE Network activity kit, and it's a really cool activity talking about designing a tool that can be used to detect an invisible force. So an invisible force is what we're looking to detect here. And this device that we're creating is called an electroscope. So if you had to guess what type of invisible force we were going to detect with an electroscope, go ahead and take a guess in the chat. Now, if we think about why scientists might need to detect invisible forces, it's because we can't always see these things, but invisible forces can still have all sorts of effects on our devices, maybe even on our human bodies, or perhaps even on the planet that we live on. So an electroscope, if we break down that word, scope means that it is a tool. It is a tool that is used for measuring, and electro, meaning you guessed it, is used to detect electricity. But not just any sort of electricity, not necessarily the electricity that's powering up my mouse here, or even the lights here inside my room. We are actually building an electroscope to detect static electricity. So I've constructed one electroscope down here on the table. So this one is fully constructed, ready to be used, ready to test an object to see if there's static electricity presence. And then the other one we'll construct together a little bit later on. But let's think about static electricity, right? What does static electricity mean? So static electricity just means electricity at rest. And the easiest way I know how to generate static electricity is by rubbing some sort of object on another. You've probably created static electricity at home if you've ever walked across your carpet with your socks on. Maybe you start to feel a little bit fuzzy, and then you reach out and touch something metal and it zaps you, right? So static electricity is the movement of electrons between two objects. When electrons move, you generate a charge, either positive or negative. A positive charge is left where the electrons have left from, and a negative charge is created when the electrons move towards that object. So let's go ahead and test out our electroscope here. Our electroscope is going to detect static electricity, and if there is static electricity present, you will see these two metal leaves in the bottom of our electroscope. You'll see them move. So right now they're moving because I'm shaking them, but I just wanted to give you a feel for what that movement might look like. But let's go ahead and give it a test. So the object we're going to be testing today is this styrofoam plate. I've just cut it in half, but if there's static electricity present on my plate, when I bring it close to our electroscope, we should see those two metal leaves at the bottom of the bottle start to move. So let's go ahead and give it a test. Now I'm bringing it in and out, but I'm not quite seeing any movement just yet. And that's okay. That must just mean that there's no static electricity present. But we talked about an easy way to generate static electricity, right? Is that I just need to create a difference in charge. So I also have some cut up pieces of felt here. But I could very easily rub this plate on the felt or on my hair or maybe even on my shirt, or a fuzzy blanket that you have at home would be great for generating static electricity. But let's go ahead and give that a shot. When we rub these two objects together, right, one is taking electrons and the other is having those electrons taken from them. So there should be a difference in charge, or what we call static electricity, being created on the surface of our plate and on the surface of the felt as well. So let's go ahead and give that another try. Zoom back in so we can see our electroscope carefully, and let's bring that object in close. Now I'm seeing some movement there, not a lot, so let's go ahead and generate maybe even more of a charge than we had just now, rubbing it very, very quickly, trying to get as many of those electrons to move as we possibly can, and testing out our plate again. There we go. Now our leaves, those two pieces of aluminum foil hanging inside our bottle, are moving. They're moving because when an object that is charged with static electricity, like our plate is, comes close to the wire starts to share the same charge. That charge is then carried down to the aluminum pieces down inside our bottle, and those become like charged as well. Now, electricity and magnets work almost exactly the same. If you know anything about magnets, we say that opposites attract, which is why a north pole and a south pole of a magnet will stick, whereas two north poles will repel or push apart. So in electricity, it works very similarly. When something is negatively charged, it will only want to attract to something that is positively charged or that is neutral. But two negatively charged objects don't want to be anywhere near each other. They're going to push apart. So when our object that is charged with static electricity comes close to our electroscope, that charge is carried down the wire to both of our leaves equally, causing a like charge, which means that they push apart or repel from each other. That causes the movement down inside this bottle. So let's talk about how I constructed this and how you might be able to construct your own electroscope at home. Now, I'm using a plastic bottle for the main part of my electroscope here, and a plastic bottle works great because the bottle itself is actually not a very good conductor. Plastic is not a great conductor of static electricity, but metal is. So I have a piece of copper wire here because copper is a great conductor. But if you don't have copper wire at home, you can also use something like a large paper clip, and you can just uncoil it to use it as your electroscope. Now I also have a little bit of aluminum foil because aluminum is another metal, and just like copper, aluminum is a fantastic conductor. So I'm just going to cut two thin leaves to act as my electroscope, the part that's actually going to move. And it's just important that they're thin enough to fit down inside the neck of our bottle. I could either poke my little wire through, or I can just really easily use something like a hole punch to give myself somewhere to hang these two leaves from. So I'm just going to take these, carefully drape them on my wire, and you'll see that I just very carefully shaped it so that there's a hook on the bottom right here where I can hang our two leaves. And then the top, I just twisted into a fun shape that I can use for collecting that static charge if it is present. And then the wire will carry it down to those aluminum leaves that are hanging down inside the bottle. Now, the leaves don't stay very easily, or this wire won't stay very easily on its own. Oh no, might need to cut one of these a little bit thinner, just so that they fit, like we said, through the top of our bottle without bending too much. But if I were to let this one go right now, my leaves would fall right down to the bottom and they wouldn't be hanging freely, being able to move. So that's why I have this chopped up piece of sponge, and I'm just going to wrap it around my wire, squeezing it really, really tightly so that it's small enough to fit inside the opening of this bottle. And once I get it right inside there, making sure that my leaves are still off the bottom of the bottle, so not touching the bottom, I can just let it go and it acts just like a plug. So now my leaves are hanging freely, and if we go ahead and generate our static charge, once again, by rubbing our styrofoam plate up against our felt here, creating that difference in electrical charge, bringing it near our electroscope, and we cause those leaves to move or repel from each other. Now, this, of course, is not the only way you could design a tool to detect static electricity. I'd like to challenge you to construct an electroscope like this one, or maybe even an electroscope of your own design at home. But I also want to talk about why we even need electroscopes. Electroscopes are actually a precursor to technology that we send on spaceships to other planets. Static electricity can actually be really dangerous for some sorts of technology. If too much static electricity gets accumulated on a device, it can actually cause it to be damaged. Just like we talked about, if you've ever gotten a static shock isn't so painful to a human, at least not a small one, but it can be pretty dangerous to a piece of technology like a robot or a rover that we send to somewhere like Mars. Now, if that rover were to be damaged when it's thousands and thousands of miles away, we can't necessarily fix it very easily. So it's important that we use tools like electroscopes to detect those invisible forces, those forces that we can't see, before they cause damage. Now, we don't necessarily use electroscopes anymore, but electroscopes were actually the precursor to a type of technology called an electrometer. An electrometer measures the type of electricity that's near an object, and it sends that information to NASA so they can know that the electricity is there. I want to highlight one really awesome scientist who's actually working in this field right now. His name is Aaron Yazzie. Aaron Yazzie is a mechanical engineer for NASA, and he actually designs tools like electrometers to send on NASA space missions. Most recently, he actually developed tools that were sent along with the Mars Perseverance rover, and that work is super important to making sure that the rover can work effectively on another planet, even though people can't necessarily make it to Mars just yet. Aaron Yazzie has a really interesting past. He's actually from a Navajo community in Arizona, and his spark or his interest in STEM came from because he thinks the Navajo desert looks so much like the environment on Mars. It inspired him to pursue a career in space, and he's innovating in that field right now. He's also won awards like the NASA JPL Bruce Murray Award for all of his work that he's doing to make sure that people feel included in STEM, especially people in Native communities like the ones that he grew up in. So Aaron Yazzie is awesome, and he's actually one of the featured scientists in our brand new kit of traveling science programs that we're kicking off this summer. Our goal this summer is to highlight diversity in STEM and to make it so that everyone, especially you, can picture themselves in a STEM career. So we've got a show here at the Michigan Science Center called Eureka, but we'll also be taking that show on the road starting this summer with our brand new Aramco Traveling Science program. We're having a big party kickoff event this Saturday right here at the Michigan Science Center, and it is free for you to attend if you'd like. All you need to do is visit the link that we're going to be posting in the chat, and you could use this link, it's coming right now, to reserve your free tickets to our kickoff event this Saturday. It's going to be outside. We're going to be doing activities like this one where you can actually create something to take home with you, but we'll also be doing some liquid nitrogen demonstrations and some other really cool activities out in front of our main doors. We have a brand new traveling science van that you'll get to check out. And of course, that free ticket also comes with admission to come inside the Science Center from 10 to noon this Saturday. So if you click the link in the chat, you can actually pick either the 10 a.m. or 11 a.m. spot, and you just need to use the discount code ScienceTravels21. That's ScienceTravels21 in order to use that code and get your tickets completely for free. So we definitely hope we'll see you here at the Michigan Science Center this Saturday. If not, of course, we'll be back here on Echo Live coming to you on Wednesdays at 2:30 with even more amazing science activities, demonstrations, and experiments that you can try at home. So I challenge you, can you create an electroscope that works better than mine? Can you create a tool that detects a different type of invisible force? I'd love to see it. Definitely take a picture, post it in the chat, and tell us about your results. Otherwise, we hope we'll see you here this weekend, and I'll see you